times width times height. And basically you've got to decide which is the length, the width and the height. And it doesn't really, it's kind of arbitrary. And depends on your perspective. I think the height is the height. Length and width can be kind of at your discretion there. Is that okay?
Mm-hmm.
So the volume here is just to multiply these three numbers together. So the volume here would be 5 times 8 times 4.
Length. Okay.
So it's a new formula. Is that okay?
Yeah.
Okay. So here's a new
down.
problem. Here's a new problem. Go ahead and find the volume for us, please.
9.
So here's what I heard. And it's my perception, is that you didn't write the formula down, you didn't put the numbers in, you just multiplied two numbers together, maybe three, but I would recommend writing down like we did, like what's the length, what's the width, what's the height. That would be the best
But they're
way
all
to,
3, aren't they?
yes. Okay, so the
So wouldn't it
formula
be
is,
3 times 3 times 3 because of formulas length times width times height?
yes, and what I'm suggesting is that there's no way you did it that quickly, because if you did write it down, you would say, okay, 3 times 3 is 9, which is what you said, but then you have to
No,
multiply it
I
by another.
didn't write that down. But I wrote the formula down
Right. So
because I just
in a
figured it
multiple
was
choice
3 times 3.
situation, I would actually have all these numbers. I mean, I would have 9 down first as the wrong answer, because it's easy to do what you just did. So keep that in mind. Just really, it's always good to write the formula down. It gives you kind of a baseline of what you're doing. And
Yeah, I have the formula written down.
all right, so number 4. All right, so again, if you could just calculate the volume for us, please.
$420.
Very good. Now, one of the things that we've not talked about here, let's just say it's meters, meters, and meters. Volume is meters cubed. All right, so I'm going to do one more here. I'm going to step away for 30 seconds while you work this one out. And let me put some units down also. Let's say it's inches, inches, and inches.
Get out of here. Go. 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 Get out.
What did you come up with for the volume here?
3.375
What about units?
inches squared.
Cubed or
No,
cubic inches? It seems like a small thing, but I suppose there's a possibility where the answer is different in units, so. Okay, good. Let's do a another problem here. Let's do a more of a word problem, more of a problem you would see in the test here. So it says a wooden crate. Hopefully you can envision what a wooden crate might look like, 5 feet along each edge. So the way you draw a box is you actually draw the front face first, and then you draw 3 parallel lines like this. And you just label it 5, 5, and 5. That's what it means along each edge, 5, 5, and 5.
125.
Yeah, so the volume is 125. Very good. You got it. So I think the hardest part is you know, maybe making the drawing or making the leap there for that. Okay, so number 7 is a working backwards problem. So we'll look at that one next. Okay, a rectangular box with a volume. So they're telling you the volume. The volume is 80 cubic feet. 80 cubic feet. Has the length and width shown. So you could say that's the length, that's the width. What is the height in feet of the box? Well, the height is what? Well, the height is the vertical right here. Okay, so what's the formula for volume? We've worked it out a couple of times.
Length times width times height.
Right, so they're telling you the length is 4, the width is 4, but do you know the height?
No,
No, but you know the volume. What's the volume?
whatever it says there. 90, 80.
80, yeah.
That's 80. It's
Okay,
not
so
80.
notice that this is an equation with one variable. You can solve this equation. Four times 4 is 16. How do you undo multiplication?
Division.
Division. So you divide by what number?
80.
I'm sorry?
80. No,
You have to look at the side with the variable.
1.
What number is multiplying age?
16.
Okay, so you divide by the number that you're multiplying by. So what number should you multiply by or divide by? Sorry.
16.
Yes. Alternatively, you could just try some of these numbers in the formula, but I think it's always better to like solve it directly if you
Oh,
can.
see, that's what I thought you were asking, because I thought you meant like what else would we divide by 16? Not like would we use the 16? So it is
So
80 that you divide by 16.
yes, and if you have a calculator, if you want to grab that,
5.
good. All right, so we're gonna do some other volume problems. The next ones that we're going to see are what are called cylinders. So cylinders are the cans. They got a circular base and then a height. Okay, so it's a different formula. The volume of a cylinder is pi r squared h. So r refers to the radius. H is the literal height. Okay, up and down height. Have you seen this before?
Mm-mm.
Okay, so you want to write it down. I'm gonna just step away for 30 seconds, grab my coffee, but go ahead and write this formula down. We're gonna use it for the next few problems. I'll be right back. All right, so the first example problem we're gonna do is number 6 from your book. It's the most direct one. So here's the problem. It asks for the volume. We need to first identify the radius and the height. Could you tell me either of those values from the drawing?
5 and no, 5 and 3.
Radius is 5, the height is 3. So the volume formula is pi r squared h. So it's pi times the radius. So the radius is 5 squared times the height, which is 3. So that's 3.14 times 25 times 3.
Two, 3, 5.5.
Okay. I'm sorry, one more time.
235.5.
Yeah, that sounds good. Very good. Okay, so let's look at another problem here. This one's a little bit different. Actually, I don't know if we want to do that one yet. Let me look for a worksheet. All right, so here's a new problem for you to try. I want you to go ahead and determine the volume of this cylinder, please.
Is it 1000? No, I think I'm putting in something wrong. Hold on. I think I typed something wrong in the calculator. No, I got the same thing. 1243.44.
Yeah, it's pi r squared h, so it's 3.14. Radius is 6 squared, and your height is 11.
And 6 squared is 36, right?
Yeah. Yep. Okay, so let's look at another problem here. This is kind of another variation on what you might see. So here's a new cylinder. Again, you need the radius and the height. What is the radius of this cylinder?
10.
It is not 10, not 10.
Oh, wait. Oh, what is?
The
Oh,
diameter,
that's not the dot. That's
the
a whole
diameter is
line.
10.
There is a dot right there. How do you figure out? Would I have to figure out the radius first?
Well, we talked about last time the relationship between the diameter and the radius. Diameter goes all the way across. The
Yeah,
radius
so you
goes from
have
the,
to half it first.
yes.
I just saw the dot in the middle and I thought that was the radius cutoff point. I didn't notice that the dots went all the way across. So it would be 5.
It would be 5. What's the height?
9.
9, good. Okay, so go ahead and calculate the volume for us, please.
$706.5.
All right, very good.
Was it 0.9?
It doesn't matter. I mean, you're rough. You're in the right order of magnitude. It depends on
14.
what you use for pi. So it's,
No.
yeah,
Oh,
whatever you have is fine.
I did 3.14.
Yeah, it's like the answer would just be 706 or 707.
25.
All right, so
It's
let's
weird. I'm
look.
plugging in those same numbers and I'm still getting 0.5. But yeah.
All right, so the other type of problem that you will see, I'm gonna have to draw it here. So sometimes a can is on its side. Okay, like you've seen that. Hopefully, a can on its side. We've all seen that. The radius. This is still the radius. Oops, I really want didn't know that. This is still the radius. Okay, the radius in this problem, I'll just say it's 9. Okay, this distance down here, I'll call this 15. This is the height. So you have to be careful here with like height. Like when you think of your height, it's your height standing up. But your height, if you're laying down on the ground, is, I mean, you still have a height. Would you agree with that, or does that sound
Mm-hmm.
reasonable? So the height is actually the distance between the circles, right? Like there's a circle over here on the right, a circle over here on the left. It's the distance between them. So when you do your volume formula here, pi r squared h, the radius is 9 and the height is 15. Is that okay?
Yeah.
Okay. You don't need to
25.
calculate that, but that's
Oh,
the type of problems we're gonna start looking at. They're just a little bit deceptive in some ways because you have to know this ahead of time. You have to understand that it's not, the vertical distance isn't really the height. Okay, so let's look at another problem here. Let's look at one you can actually try here on your own. I want you to tell me the radius and the height though before you proceed.
that does go all the way across. Yeah, it does. Okay. So 25. Is it 863.5 centimeters?
So one of the things, one of the reasons I ask you, I don't know. One of the reasons I ask you for these two numbers first is because if
Oh,
they're
5
wrong,
is the radius and 11 would be the height.
yes. And the reason, yeah, the reason I want you to get this first, because if they're wrong, then your answer is wrong. And then from here, it's really just a matter of putting it in the calculator correctly. 5 squared times 11. All right, good. So let's do your practice problem, and then we'll do some of the other problems in the book there. All right, so here is, again, just it's asking for the volume on this one. So go ahead and calculate the volume for us, please.
Is that diameter?
Yes, that is the diameter.
Okay, because I couldn't tell because it was a straight line all the way across. I didn't know if that was different. So it'd be 3 would be the radius and 5 would be the height.
Yep.
So okay. 3 times 3. Could it be 141.3?
All right, really good. So that takes care of kind of those like worksheet problems. And then the next question 9 is they got another kind of a story problem here. So we can look at something with a pull. So when you see a problem like this, you're supposed to immediately recognize that this is a cylinder. So it says Linda adds a water stabilizer to her children's swimming pool once a week. The instructions tell her to add 1 scoop of the product for every 20 cubic feet of water. About how many scoops should she add per week? Okay. So the first thing I need you to do here is determine the volume of the pool. That's always a good step.
So the radius would be half of 12. Would it be 56.52? Would that be the volume?
It is not. It is not. The radius
Oh
is
wait,
6
this
though.
isn't. We're not doing the same thing. We're doing regular volume, not
Okay.
cylinder. Right? Or no?
There's only one formula for volume. It's
I'm confused.
pi r squared h.
Oh. So 6 is the radius, right?
That's right.
So wouldn't that be the volume? Hold on. 3.4 times 6 times 3 times no wait. 6 times 6. 36. $339.12.
Very good. So that's the first. That's the start to this problem here. So that's a really good start. Let me. So the rest of it is there. So you said the volume is about. Let's just call it 340. Okay, 340, nice rounded number. So you put in 1 scoop for every 20 cubic feet. Okay. So if you could think of it, if it in a table, you're like scoops. volume, 1 scoop for 20, 2 scoops for 40, and so on. You see that?
Yeah.
All right, so if you wanted to figure out 340, you would have to go backwards, right? How many is it? Well, notice that you divide by 20 in each of these cases. So what is 340 divided by 20?
17.
Okay,
So the answer C.
you got it. Good. Very good. So that's kind of it for volumes. I mean, excuse me, I don't think we need to like go into any more detail on this unless you say, hey, you know, I really want to learn more about it. Kind of up to you.
I think it's okay. I think
I
I
feel like
have
we've,
um, I have the
yeah,
formulas written down, and then I have a couple examples.
okay. That's good. So, you know, that's everything for volumes. And now we can look at some of the other pages that you sent here. We did volumes, we did volumes. There are more volumes, so maybe we should spend a little more time on volumes, pyramids,
Okay.
tones. I don't
There's more
know.
volumes.
Uh, I don't. I mean, they're okay. Yeah, we'll spend some time on these. We might as well hit everything in volumes. All right. So I'm actually just going to find a worksheet that would be a little bit better for us to do than this. Okay. Um, slightly more complicated than what we've been doing. You ever been to see a pyramid? Maybe I don't know, the Luxor in Las Vegas, or maybe you've been to Egypt.
No, but I know what a pyramid looks like.
Okay. Yeah, I've only seen the Luxor. It's the only thing that came to mind. So the volume of a pyramid, this one's a little bit more like, I don't want to say this, it's more general. So it's 1/3 the area of the base times the height. Okay, so the base is kind of the big thing here. The base is the thing that sits on the ground. Do you see that there's a rectangle that sits on the ground in this problem?
Yeah.
So that's the base. So what is the area of the base in this problem?
Um,
How do you find the area of a rectangle?
area would be volume. Would it be base times height?
Yes, and one of the problems is we're reusing like words. So the base refers to the base of the pyramid. Base of the rectangle is 10, height is 8. So it's 10 times 8.
So it'd be 80.
80, yeah. The base is 80, so the volume of the pyramid is 1/3 times 80. The height is 7, so the height is literally like when you or I stand up, our height, the height is the height. There's nothing else there.
How would I multiply 1/3 by something?
So you can wait till the end and divide by 3. So you could do like 80 times 7 and then divide by 3 like that. It may not work out, perfectly, but it'll work out.
Yeah, I don't get it.
Multiply 80 times 7 and then divide by 3.
Yeah, would it just be, would I get rid of all those numbers at the end? Cause it is something that has just like a 0.66667.
I mean, we don't know. Like a lot of your problems here have been just whole numbers, so probably, I mean, I don't know exactly what you're going to see on the test. These are whole numbers. Sure. I mean, you just have to be better at just saying, okay, I'm just going to do the calculation, whatever it is. So what do you have for me? What is the,
It's like 186.666667. So I guess
286 you
just
said?
186.
Okay, 186 or 187, sure. That's fine. Okay,
Yeah, it would
so let's
round
have you,
up to, so.
it mean you're close enough. The answers aren't going to be that close together. So here's a problem to try on your own that's really, really similar, just different numbers. So give this one a try, please.
How would I do this one?
Go back and look at what we did in the previous problem.
Well, because it
What's
would be
what's the formula for the
like
volume
2
of the pyramid?
times 1.
Okay, so you have to
So that would
first
just be
find the area of the
2.
base.
Wouldn't it be 2?
Okay, keep going.
And then 4. So then you would, no. Can I look at the other one again?
Sure.
Oh, so you wouldn't add them together first. So it would be, so it'd be like 1.3.
So that's good. I heard a lot of the right things. So 1/3, the area of the base is 2 times 1 and the height is 2. So yeah, it's 4/3 or 1.3333333. Write that. Good. Okay, let's have you try one more and then we'll move to kind of a related type of problem. Let me see if I can, yeah, put this in here. Yeah, there we go. So go ahead and find the volume of this, please.
$112.
So 1/3 6 times 8 times 7. Is that what you have?
Yeah.
All right. And so 112. Now the units here are feet. Feet
Oh yeah,
cubed.
feet
Feet
cubed.
Yeah, but I mean, we don't know what they're going to do on the test. We're not, we're not 100% sure. So let's have you try a couple from the book here. Just because these are, whoop, try that one more time. All right, so here's one from your book.
Would it be 9?
Yes, 9 inches cubed. Good. Okay, so we'll look at kind of a related problem. The like with the cylinders, the height is the actual like height. Like this is a pyramid that's on its side, but the height in this problem is the 8. Like you might visualize it like rotating up and sitting on this. But go ahead and calculate the volume on this one for us, please.
So would it be length times width times height?
Nope. What is the formula for volume of a pyramid?
Oh, that's also a pyramid.
Yes, it's a pyramid that's on its side.
Like 10.6?
Yeah, how did you
10.6 or
come up with
10.7?
how did you come up with that? Tell me what you did.
2 times 2, and then that would make 4 for like the area, and then 4 times 8 divided by 3.
Okay. And then times the height 8. Yep. Good. Okay. Really good. So actually there's one more problem in your book I might as well have you do. Nah, let's move to cones. So the next type of problem is a cone, volume of a cone. So there's 2 types of cones that you'll see. One is the party hat. If you've seen that, or the ice cream cone, if you like ice cream. The volume of the cone, very similar to the volume of a pyramid. It's 1/3 pi r squared h. So again, you need that radius, and you need that height. All right, so this is something to get down in your notes. Make sure you've got,
Yep, I'm
reference
writing
for.
it down. Or okay.
Okay, so we're going to look at a few more problems here. So we'll just start with kind of the generic one here. So here's a cone. Here is a cone like this. So volume is 1/3 pi r squared h. The radius is 24. The height is 43. So it's 1/3 3.14 24 squared times 43 like that. So it's a lot like what we've been doing. You just have to put the numbers in the right formula.
So it would be, let's see, 24 times 24. So 576. See 3.14 times, what was it? I got like 25,923.84.
Yeah, so sometimes the numbers don't really mean anything, right? They're just whatever, right? So, but the point is to be able to put them into the formula here, which is what we're doing. So let's look at another problem. Let me just throw this one in front of you. Like sometimes the answers don't make much sense. Mostly I care about you just getting it into the formula and working it out
But
here.
they're the right answers?
Yeah,
Mostly?
yes, that was correct.
Okay.
So if you could for this one, make sure you use the correct number for radius. Sometimes it's easy to overlook that little step.
The one that has the dot in the middle sometimes. I don't notice that the line goes all the way through.
Yeah, so what is the radius in the
22,
yeah, 22, and the height is
51.
51.
Or 84.
Is that your final answer?
Oh no, that's the
Okay.
22 squared, I think. If I put it in right, and then times 51 divided by 3. Let me try that again. Oh. So 25,835.92.
Okay, good. Very good. Again, the numbers don't really mean much. We're just working on formulas and stuff like that. Getting them in there. You're doing a great job. So let's go back to your book real quick here. So number 3 in your book is the cone on its side, okay, which you might see. So in this problem, what is the radius and what is the height of this cone?
That cuts off in the middle, right? So that
Yes,
would be the radius would be 5 and the height would be 12
really good.
centimeters.
Yeah. Yep. So let's look at a couple of more here. We'll just set them up. You can work on it later if you want. I don't know if this is the picture or the book or both, but this is one ugly cone. Looks more like a triangle. What is the radius and what is the height in this problem?
Um, mhm. Would the radius be 4.5?
Yes.
Okay.
And what is the height?
And then the height 6.
Good. Okay, and one more here.
So it would be So for that one,
You may have just cut out. Maybe you muted yourself. It's like you did. There you go. You're back.
there you go. I think I swiped that on accident. And then this one, the radius would be 7.5 and the height would be 16.
It's actually 18 there.
Oh,
Good.
18.
So,
Oh,
so keep
sorry.
in mind, this is really important. We keep in mind, like everything we did today, like I said, this is a prism. Here's the formula. This is a cylinder. This is the formula. This is a pyramid. This is the formula. This is a cone. This is the formula. You have to be able to do these mixed. You know, you need to be able to work, do like a mixed review of volumes. And that's what we didn't get to today. Like I didn't just like throw one up and say, okay, figure out what it is and what the formula is. So we might do that next time, I guess, is one thing we could do. But
Okay.
if not, we'll just move on to your other stuff here that you've sent over. So we are going to stop there for today. Go ahead and stop the recording.